Okay, everyone. The next talk is The State of Ganeti by Rudi Bott.
Thanks. Hi, everyone. Today I'll tell you a bit about the state of the Ganeti project as it currently is. Just a quick survey. Who knows or who has heard the name Ganeti? Who has used it? That's odd. Okay. So I'll quickly tell you what it actually is, in case you don't know. We'll dive a bit into the question, is the project healthy or is it not? And also take a look at how easy it is to contribute or to test. And a small commercial break. Me and some colleagues are actually working on a web front end for Ganeti, which makes it easier to adopt and use, and I'll show that briefly. Just to myself, I am one of the maintainers of the Ganeti project, and spoiler, we're not that many. So what is Ganeti? Actually, it's a virtual machine cluster management tool. So it was originally developed by Google, I think, at around 2006, 7, 8 or something when they started. They used it internally, open sourced it around that time, and I think one of the founders or first contributors was Guido Trotter, which probably some people know from the Deepin project. But then the development stalled at some time around, I don't know, 2018. We'll see that later. Because it was, well, it seems like Google was done developing it. They used it, but it was finished. And that's when it came to a halt entirely at some point around that. So finally, a community formed around the project, and Google officially transferred all the resources to that community. All the assets are currently owned by SPI, which probably most of you know. And that's a bit to the history. So what can you do with it? It scales between 1 and tens of nodes, and a node is a host running VMs. The number of instances, which is the Ganeti term for a VM, is actually only limited by physical resources, for example, the number of nodes, memory, CPUs, etc. And everything you need is available with a standard Debian installation. So you can just install Debian, type in apt-get install Ganeti, and set up a cluster or a single node cluster or multi-node cluster. So there are no external dependencies, nothing fancy to set up. It just works. Some of the features of Ganeti is it allows for automatic instance placement and cluster balancing, so it takes care of putting your instances across your cluster in an even manner. It allows for live migration, although that depends a bit on the hypervisor used and the storage. It has support for VirtIO or emulated devices, that also depends on the hypervisor. And it has a so-called OS provider interface that allows to set up instances, for example, through debootstrap or other means, or like an image-based provider. Or you can also just, for example, fall back to PXE-boot and do it externally. Management is done through a CLI or a REST API. Both works equally well. And it knows about a bunch of hypervisors, or let's say hypervisors. I guess the first-class citizen by now is actually KVM, although I guess it used to be Xen. This is where Google started off. For KVM, it works with fully and semi-virtualized, which means direct kernel boot for those who are more familiar with KVM. Xen also works with HVM and PVM. It also supports LXC, although this has been rather untested, so I don't know if that actually still works. It's officially unsupported because we don't test it anymore. It also has support for a so-called change root supervisor, which actually just runs something a change root. Don't know if that uses anyone. And it also has something that's called a fake hypervisor, but we'll come to that later. Data is stored using different means. It knows, for example, a file backend, which is just a local folder which has image files. It also has an exception to that. It's called a shared file, this just adds the assumption that this folder full of images is somehow magically present on all nodes. For example, if you use NFS or whatever means to do that. And with that extension, you're, for example, able to use live migration. With the plain file backend, you only can use some kind of offline migration because it just shuts down the instance and moves it over to the other node and starts it again. LVM has, let's say, the same restrictions. It's only local, but you might add in DRBD. That's, for example, something that we use at my employer, which means you get instances that are always mirrored to one other node in the cluster, which is in most cases actually good enough. It can also run on Ceph or Gluster, although those two options are also officially untested right now, mostly due to the lack of manpower and knowledge. And there's also external storage providers, which means you can just throw in your own scripts that actually adhere to a simple API that may be used to, for example, add custom storage solutions. Networking is done through standard Linux bridges. There's also a routed mode and Open vSwitch, and you can mix and match everything I just showed you, like the hypervisor types, the storage types, and the networking types. So there's probably something for everyone in there. So how active is the project? As you can, I just shamelessly copied this off GitHub. As you can see, it started around something 2007 or 8. At least that's how far the Git history goes. And it seems to have had its peak around 2014, and it just went down from there. With some minor stuff happening in the last years. There haven't been many feature additions recently, but you could also argue that it's mostly feature complete for what it wants to do, and probably has lots of hidden features. At least I've been working with the code base for a while, and I tend to find out things that I didn't know that even existed. These are pull requests that have been closed in the last, accepted in the last month. And if you can read it, I don't know, there are only 2 names currently, so that's probably some kind of a hint where things are going right now. So it is actually, things are happening, but they're happening slowly, and we only have a small base of people involved. There are some former developers from Google who sometimes lend us their time for reviews, but they are also busy and work on other things as well. So that's just on a best effort basis. However, we do have lots of active users, which is good. People open issues. They use they contact us through ISC or through the mailing list. They help each other. They sometimes ask for features, but as I said, it seems to be mostly working for everyone. What's semi-good is we have only semi-active contributors. As I said, there's only few people involved right now. Although we are apparently attracting new first-time contributors. They usually do small changes, but nevertheless, that's a start, I guess. But I guess you could say that the project is mostly in a maintenance mode. So what we're doing right now is, or the fixes from the last 2 or 3 years, we're migrating from Python 2 to Python 3, which is probably mostly maintenance work. That worked out well, by the way, and we're adapting to changes that are happening in the ecosystem. For example, adapt to QEMU changes, Xen changes, other things like the storage systems involved. We might have to move to DRBD9 at some point in the future, etc. But these probably can't be considered features because it's just keeping it alive, more or less. It works well, but as I said, no new features. So is it easy to contribute? Well, it depends. It's a large code base. It's mostly Python, but there's also a good portion of Haskell, and at least that's where I'm out of the game, because I really don't know anything about Haskell. One of the goals is actually to, in the long run, remove or replace the Haskell parts with Python. However, that would probably mean that someone needs to understand what the Haskell part actually does. So that's a problem. It has many abstractions, which is great for testing and great for the code base itself, but it makes it hard to actually understand how things go or how things work when you try to look at it for the first time, and you just want to do like a simple change, but you instantly get trapped into abstraction levels. And the interactions between the Python and the Haskell world are sometimes complicated, at least at first, because it just goes back and forth between both worlds when you deeper you dig. However, we have removed the Google contributor license agreement, which was present when we took the project over from Google. That was mostly due to relicensing that happened in the past. It's currently a BSD 2 license, and Google assumed that they needed the CLA to avoid issues due to the relicensing. However, I don't know if any one of you has dealt with the CLA or with the Google CLA. You need a working Google email address or Google account for that, so that's quite a burden. So in the past, you could observe that people opened a pull request because they want to change something. Then Google bot comes around and says, "Well, have you already signed the CLA?" They say, "No, let me do that," and then you hear never again from them, and you're stuck with some dead pull request that just floats around. So we have removed that because we don't feel that we need that anymore, and it makes contributing way easier. So, as I said, it's a complicated code base, it has lots of dependencies, and it does things as virtualization. That's probably hard to test. How can you test it? Luckily, it ships with a rather large QA suite, which is able to test a cluster in many, many ways. For example, create instances, test different storage types, and move around instances, do live migrations, use many different QEMU or Xen parameters, and do tests again. But it also supports a so-called vCluster, which means you can just spawn a fake cluster on one node or your local workstation. It uses a so-called fake hypervisor, which is a hypervisor that just always says, "Yes, I did it." And you can run so-called diskless instances, and with that you can actually simulate 3 or 5 or 15 nodes on your local workstation or in a Docker container and do some basic testing. And you can also use the QA suite for that. But the real deal is actually using something like nested KVM. And my employer, for example, has sponsored a real server for that. And we use it to test even Xen and also KVM as nested KVM. I guess in a setup that's close to real world, it actually simulates everything except Ceph and DRBD, because Ceph and cluster, because at least I'm not familiar with those two storage types, and just setting up something that looks like Ceph is probably not going to have any real world value. And then again, you can also run the QA suite or test with real hardware, like an entire cluster of real hardware, but that's of course very expensive and time-consuming. Like the QA suite is easy to, or at least with some magic that we have added around that, it's easy to start. It just takes long. So this is like a reduced test set for KVM, but the usual runtime is 4 or 5 hours to have like a decent idea of, is it still working? And sometimes you run into issues due to KVM or hardware and stuff, which is probably not directly Ganeti related, but you still need to check those. So this is rather tedious. But still, you get a quite good idea if it still works. So that again makes contributing easier, and we also have a means of triggering these tests through GitHub Actions. So we don't run these tests on each commit because it just takes way too long. But you can, at least maintainers can add those manually to tests, to pull requests. This is something I did in the last days. We now have a simple website which just lists all those QA runs that the machine does, and also gives you access to the log output of all the machines involved, because it's, as I said, it's always a cluster of at least 3 nodes. So you get lots of distributed output and logs somewhere floating around, and you need to check everything if you want to examine like a failed thing, for example. So this is the last part about the so-called GNT-CC API and frontend. That it's currently located at this repository URL, but it might move to the Ganeti organization soon, maybe. It's actually quite simple. It has 2 parts. It's an API written in Go, and the advantage of this API is, for example, it adds a better authentication. It has local authentication and LDAP based, and it can add, or you can have as many clusters as you want behind that one API. So you can, for example, run 10 or 5 or 15 clusters, but have one single entry point to access all of them. And it also comes with a front end, which is written in JavaScript and React, which is very far off from things I can do, but I know people who can do that. And as it's easier to see some pictures than just describing it with words, I guide you through the front end. So what you can see here is like a basic overview site. You can pick your cluster with the drop-down box. It's probably hard to recognize on the screen on the top left side. You get some basic stats. And of course, it also has a dark mode, which is apparently nowadays mandatory. You can get, for example, node overviews, how many nodes you have on your cluster, what's like the current resource usages, and how many instances are there. And you can also see here, this is it's pretty balanced. So this is something that Ganeti can do automatically for you. It has a built-in access to a VNC console if you have one enabled or configured through WebSockets. That works quite well. This looked better before I had to redact all the host names, so sorry for that. Recently we added a search bar. It's available through a keyboard shortcut because, as I said, we have at my day job we have lots of clusters, so let's say 6 or 7 or 8. And especially on-call people who need to reboot or whatever due to an instance at night, they spend a lot of time trying to figure out which cluster to check for the VM that's actually going mad. So with this, you can just hit a shortcut and just type any part of the host name, and it will just directly bring you to instances, nodes, or clusters that match that name. So that's quite neat and works well, or at least for keyboard-orientated people, that's very neat. Sorry for the bad quality again. Most things Ganeti does work as background jobs, for example, starting instances, migrating instances, restarting, shutdown, etc. And we have like a sort of job tracking. When you, for example, click on the migrate button, you will see a small pop-up. You can follow that job and see when it's done. So that's easier to track than tracking jobs manually. But of course, all those things and many more can be done through CLI as well. So using a dark SSH terminal is sometimes more convenient if you get up at night during on-call. So whatever floats your boat works. So thank you. That was a quick overview of the project itself and what it does and where we are. If you have any questions or any ideas how to improve the situation, please let me know. Thanks.
So, any questions?
So, what kind of tests are you running to see that your node or instance is working or behaving properly?
You mean during.
You mentioned this test suite.
Yeah.
What does it do? Does it check for the node getting up and that's fine and that's all, or are there way more complex tests following that?
Yes, there actually it tests various aspects of the cluster. For example, if the nodes are healthy, if you can change aspects of the node configuration, and it does positive and negative tests. So it tries to change things that should work and checks for that, and also tries to change things that shouldn't work and check for that as well. And it just goes through the other aspects of Ganeti as well. For example, creates instances, so guests, and moves them around and changes aspects or renames stuff. Pretty much anything you can do to an instance gets tested. And the same applies for other aspects like the networking part or the storage part or the job management for the background jobs. So it's actually, when Google left, they left something working. And you just need to dig through the code base and find those gems and then use them. So it's actually it's pretty complete what we can test. However, you should never run the test suite against the live cluster, because after that you won't have that anymore, because it will just stop and start and delete and insert random things.
Okay, thank you.
And it also has of course unit testing for the Python and the Haskell parts.
Did Google stop using Ganeti when it moved it to the community?
We don't know.
Okay, I was going to ask why, but
there have always been rumors for what they were actually using it. As far as I know, or at least they claimed, it was never used for products like search or whatever, but it was in use for branch offices, and as far as I know, a Google developer is always provided with for example, a Chromebook or working environment and a remote machine to actually run or execute stuff, and those machines were provided, or maybe are still provided, on Ganeti, and of course branch office infrastructure stuff. But that's all that got leaked to the public, as far as I know. And for example, there are universities using it quite a lot in Europe and the US. There are companies like Zipgate. We run around 900 instances on 7 or 8 clusters. There are also other companies like Spreadshirt, I think, who did run a similar amount of instances. So that it's from a user perspective, it's not that at all. Just the development has slowed down a bit. Oh yeah, sorry, I forgot that.
okay, so as I said, Debian is using it and OFTC is using it as well, but that's a single node installation on one machine, and
we have those as well.
We lack people daring to touch it.
The web UI looked really nice, but it reminded me a little bit about what the Foreman does, and I wonder if you kind of like considered like writing it as a Foreman plugin rather than doing your own project for managing the machines.
That's too late now.
Okay.
Well, we also know and used Formans, but it started off as a side project, and well, that's where we ended now. And yeah, but now that you said it, I think most of this stuff could be integrated into Foreman, I guess. Or it might fit the general approach that Foreman takes.
Okay, any further questions? No? Okay, then thank you very much for your talk, Rudy.
You're welcome. Thanks.